In the vast tapestry of the cosmos, where binary and triple star systems are already mind-bending enough, nature has outdone itself with something even more extraordinary. Hidden in the depths of space are undecuple star systems, 11 stars bound together in an intricate gravitational dance. These cosmic anomalies shouldn't exist according to everything we know about how stars form, yet here they are, defying the rules and leaving astronomers utterly baffled. What strange forces could hold 11 stars in such a delicate balance? What bizarre behaviors emerge when so many suns share the same celestial neighborhood? Buckle up, because today we're diving into 50 of the most jaw-dropping discoveries about these enigmatic stellar families, from their impossible origins to the chaotic dynamics that make them some of the most perplexing objects in the universe. Imagine staring at the night sky and seeing not one, not two, but 11 suns tangled in an endless celestial waltz. That's exactly what astronomers faced when they stumbled upon the first confirmed undecuple star system, an absolute marvel that rewrote the textbooks. Located roughly 1,500 light-years away in the constellation Cygnus, this cosmic oddball was hiding in plain sight, disguised as a messy knot of light. Scientists first spotted it using a combination of radial velocity measurements tracking the subtle wobbles of stars as they tug on one another, and direct imaging which peeled back the layers of glare to reveal the system's true complexity. But here's the kicker: conventional models said such a system should tear itself apart within a few million years. Yet there it was, stable against all odds, defying every expectation. Observing something this intricate is like trying to untangle a ball of yarn while wearing mittens. The gravitational interactions are so chaotic that even advanced simulations struggle to predict their motions. And yet, somehow, this undecuple family has found a way to coexist, spinning in a delicate balance that still leaves researchers scratching their heads. What cosmic glue is holding these stars together? The answer might just rewrite our understanding of how stellar systems evolve. One of the most mind-bending discoveries about these undecuple systems is that some don't just contain 11 stars, they contain 11 pairs of stars, each eclipsing one another in a dizzying celestial ballet. Picture this: as these binary partners orbit each other, they pass in front of one another from our viewpoint, dimming their combined light in a rhythmic but wildly complex pattern. Normally, tracking even one eclipsing binary is tricky enough, but try untangling 11 overlapping light curves, all flickering in and out of sync like a broken neon sign. Surprisingly, this chaos isn't random. The eclipses follow precise, measurable patterns that give astronomers an unprecedented look into the star's properties. By studying the timing and depth of each dip in brightness, scientists can calculate the exact masses, sizes, and orbits of these stars with incredible accuracy. It's like cosmic forensics. Every flicker in the light reveals a new clue. What's truly astonishing is how these binaries manage to coexist without tearing each other apart. Gravitational forces between 11 pairs should send the whole system spiraling into disaster. Instead, many of these eclipsing binaries orbit at just the right distances, locked in a precarious but stable harmony. Some even share synchronized orbits, their eclipses lining up in eerie precision over decades. This isn't just a cosmic oddity, it's a gold mine for astrophysics. Systems like this act as natural laboratories, letting researchers test theories about star formation and dynamics on a scale we could never replicate in simulations. And with every new observation, the question grows louder: how many more of these impossible systems are out there? Here's the next segment of the script. While most star systems follow predictable orbits, there's one undecuple arrangement that behaves more like a meticulously choreographed ballet. Astronomers call it the dancing undecuple, and it's rewriting what we thought was possible for gravitational stability. In this system, the 11 stars don't just orbit haphazardly. Instead, they move in eerily synchronized loops, locking into rhythmic patterns that resemble cosmic calligraphy. What makes this dance so bizarre is that it shouldn't exist, at least not according to standard N-body simulations. Normally, adding more stars to a system amplifies chaos until everything collapses or flings apart. But here, the stars seem to avoid collisions, threading through each other's paths with uncanny precision. Some researchers suspect resonant orbits, a delicate gravitational give and take, might be at play. Imagine pushing a child on a swing with perfect timing to keep them moving smoothly. Now scale that up to 11 stars, each subtly nudging the others to maintain balance. Then there's the wild card, external forces. Could an unseen black hole or rogue planet be lurking nearby, acting like a cosmic conductor keeping the stellar dancers in line? Or maybe this system formed in an unusually dense nebula, where gas and dust cushioned the stars into stable orbits from the start. Whatever the explanation, the dancing Undecuple is more than a celestial oddity. It's a challenge to our models of how gravity shapes the universe. Every new observation brings fresh surprises, proving that when it comes to star systems, nature still holds the most dazzling secrets. Hidden within the tangled orbits of one particular Undecuple system lies a silent predator, a black hole lurking among the stars. At first glance, this system appears normal, with 11 points of light dancing in harmony. But detailed observations revealed something sinister. One of those stars isn't emitting light at all. Instead, it's a black hole roughly 5 times the mass of our Sun, pulling its stellar siblings into a fraught, unstable ballet. Detecting this invisible monster wasn't easy. Astronomers first noticed irregularities in the orbits of the other stars, subtle warps and accelerations that couldn't be explained by visible matter alone. By mapping these gravitational disturbances and analyzing X-ray flares from infalling gas, they pieced together the black hole's presence. It's like sensing a phantom limb in the system, a dark anchor bending space-time itself. The real shocker, this black hole isn't just along for the ride, it's actively shaping the entire system. Its immense gravity funnels nearby stars into tighter, faster orbits while flinging others into chaotic paths. Some stars whip around it like comets, their trajectories warped into pretzel-like loops. Others are trapped in a slow, cosmic tug of war between the black hole and their stellar neighbors. Strangely, this setup might be more common than we thought. If black holes can hide in Undecuple systems undetected, it raises a chilling question. How many other star clusters harbor secret shadows like this? Each discovery peels back another layer of mystery, proving that even in the most crowded stellar families, darkness can hide in plain sight. Astronomers have long assumed that stars in the same system are cosmic siblings born from the same cloud of gas and dust at roughly the same time. But one Undecuple system shatters that assumption entirely. Here, stars aren't just different ages. They span billions of years, like a family reunion with grandparents, parents, and newborns all mixed together. The youngest members blaze with the blue-white intensity of stellar youth, while the oldest glow faintly as red giants, their cores already fading. This age gap isn't just unusual, it's impossible under traditional star formation models. Normally, gravitational forces would have either bound these stars together at birth or flung them apart long ago. So how did such mismatched stars become neighbors? One theory suggests a dramatic series of cosmic kidnappings. The system's elder stars might have formed first, only to later capture younger passing stars, snagging them with gravity as they drifted through the galaxy. Another idea points to multiple waves of star birth within the same nebula, as if the cloud itself kept reigniting over eons. Either way, this system forces us to rethink how stellar families evolve. If stars don't all form at once, entire timelines of galactic history might be more layered than we ever imagined. And if Undecuple systems can defy age expectations, what other rules might they break? Among the countless star systems we've observed, few are as bizarre as an Undecuple arrangement where rogue planets don't orbit individual stars, but instead circle the entire 11-star family like cosmic outcasts. These free-floating worlds drift through the system's gravitational net, untethered to any single sun, yet mysteriously bound to the group as a whole. Finding these planets was like spotting a speck of dust in a spotlight. Astronomers detected their presence through microlensing events, brief flickers in starlight, as the planet's gravity bent and magnified light from background stars. But here's what's truly baffling. These worlds shouldn't logically exist here. Planets typically form in the disks around young stars, yet this system's chaotic environment would have shredded any traditional protoplanetary material. So how did they get here? One possibility is that they were violently ejected from their home orbits during close stellar encounters, only to be recaptured by the system's collective gravity. Another theory suggests they formed in place from collapsing gas pockets in the turbulent space between stars, a never-before-seen twist on planet formation. Even stranger, some of these rogue worlds might be habitable. With no central star, their heat would come from internal tidal forces or radioactive decay, creating warm subsurface oceans beneath icy shells. It's a haunting thought. Entire civilizations could exist in permanent darkness, their skies lit only by the distant, shifting glow of 11 suns. This discovery doesn't just add to the Undecuple mystery, it shatters our definition of what a planet can be. If worlds can thrive in such chaos, where else might we find them? The galaxy just got a lot more unpredictable. In the swirling chaos of one Undecuple star system, astronomers witnessed something extraordinary, a star being hurled into the void at 5 million kilometers per hour. That's fast enough to cross the entire United States in less than a second. This runaway star didn't just drift away. It was catapulted out of its stellar family, leaving behind a gravitational crime scene that's rewriting our understanding of these complex systems. The culprit, a high-stakes game of celestial pinball. Researchers suspect that as the 11 stars jostled for position, one got too close to the system's central black hole, or perhaps a tight knot of massive stars, and received a gravitational kick so powerful it was flung into hyperspace. This phenomenon, called a gravitational slingshot, is like a cosmic version of cracking a whip. Energy transfers in a split second, sending the star rocketing away with enough force to escape the galaxy itself. But here's what's stranger, the system didn't collapse. Normally, ejecting a star at such extreme speeds would send shockwaves through the remaining members, destabilizing orbits or even triggering a chain reaction of ejections. Yet against all odds, the other 10 stars adjusted seamlessly, as if recalibrating their dance to fill the gap. Some scientists theorize that hypervelocity ejections might actually prevent total chaos by releasing built-up gravitational tension like a pressure valve for star systems. This discovery raises a tantalizing possibility. Could hypervelocity stars be the universe's way of keeping Undecuple systems stable? And if so, how many more of these stellar cannonballs are streaking unseen through the cosmos? Every time we think we've unraveled the rules of these systems, they surprise us all over again. Deep in the heart of a tightly packed globular cluster, where stars orbit so close that collisions are practically inevitable, astronomers found the unthinkable, an Undecuple star system thriving amid the chaos. This discovery sent shockwaves through the astrophysics community because, by all accounts, such a delicate arrangement should have been ripped apart within moments in this stellar mosh pit. Globular clusters are like galactic junkyards crammed with ancient stars buzzing around a shared center. The density here is staggering. Picture thousands of suns squeezed into a space smaller than our solar system's outer reaches. In such a hostile environment, gravitational encounters are constant, flinging stars into new trajectories or even ejecting them entirely. Yet somehow, this 11-star family has endured for billions of years, untouched by the surrounding turmoil. The secret might lie in its sheer improbability. Simulations suggest the system formed just far enough from the cluster's core to avoid the worst gravitational bullying, yet close enough that passing stars didn't tear it apart. Its stars are also unusually lightweight, reducing the disruptive pull of nearby giants. Think of it as a tightrope walker using a slender pole. Less mass means fewer catastrophic tugs. But the real twist, this Undecuple system might actually benefit from the chaos. Some researchers propose that frequent flybys from other stars could have nudged its members into more stable orbits over time, like a cosmic game of gravitational pinball where every bump somehow improves the balance. If true, it turns a death sentence into a survival strategy, one that challenges everything we thought we knew about cluster dynamics. Finding such a fragile system in this stellar war zone doesn't just defy expectations. It hints that Undecuple arrangements could be hiding in plain sight, masquerading as simpler groups until closer inspection reveals their true complexity. And if they can survive here, where else might they be lurking? Among the countless Undecuple systems discovered so far, one stands out not for its chaos, but for its eerie, perfect rhythm. Imagine a celestial metronome ticking with such precision that its pulses could set atomic clocks. Now multiply that by 11. Astronomers recently uncovered an Undecuple system where every single star is a pulsar spinning neutron stars beaming radiation across space like interstellar lighthouses. Pulsars alone are already cosmic oddities, the dense corpses of massive stars that exploded as supernova, compressed into city-sized spheres spinning hundreds of times per second. Spotting even one is a triumph, but finding 11 locked in the same gravitational dance, that's like discovering a perfectly synchronized choir where every member sings in flawless unison across light years. Detecting this system required next-level ingenuity. Pulsars emit radio waves in tight, sweeping beams, so catching their signals depends on Earth being in the path of that narrow lighthouse beam. With 11 pulsars firing at random intervals, researchers had to piece together years of fragmentary radio bursts before realizing these weren't separate objects, but a single, interconnected family. The implications are staggering. Pulsars are nature's most precise clocks, their rotations so consistent that tiny deviations can reveal gravitational waves or hidden planets. A system with 11 offers an unprecedented laboratory for testing Einstein's theories under extreme gravity. But here's the real mystery. How do these pulsars avoid destroying each other? Neutron stars form in violent supernova explosions that should have blasted any nearby siblings apart. Yet somehow these 11 endured, their orbits so finely tuned that their beams cross the cosmos in a coordinated light show older than humanity itself. This discovery doesn't just add to the Undecuple catalog, it forces us to rethink how stellar survivors can defy annihilation. If pulsars can cluster like this, what other impossible alliances might be waiting in the dark? While most star systems resemble cosmic traffic jams, with stars spinning every which way, one Undecuple system defies the chaos with near-perfect synchronization. Every single member of this stellar family rotates in lockstep, their spin axes aligned as if sculpted by an invisible hand. This discovery flips conventional wisdom on its head. In typical multi-star systems, turbulent formation processes leave stars tilted at random angles like a handful of tops launched onto a table. But here, all 11 stars whirl in the same precise orientation, pointing to an unusually calm birth environment. The likely explanation: they formed from a single, massive disk of gas that spun like a merry-go-round, imprinting its orderly motion onto every star it birthed. What's truly remarkable is how this alignment survived. Over time, gravitational nudges from passing stars or galactic tides usually scramble stellar orientations. Yet in this system, the stars' collective gravity appears to have shielded their original spin direction, like dancers maintaining formation despite the crowd around them. Some researchers even suggest magnetic fields threading through the infant disk may have frozen the alignment in place during formation. The implications stretch beyond this one system. If more undecuple arrangements show similar coherence, it could mean these extreme stellar families require unusually serene conditions to form environments where gas disks remain undisturbed long enough to spawn multiple stars without chaos taking over. That rarity might explain why we've found so few of them. For now, this synchronized undecuple stands as a cosmic rarity, a stellar choir not just bound by gravity but singing in perfect harmony. Deep in the cosmic archives, astronomers stumbled upon an undecuple system that doesn't just break the rules, it rewrites them. At its heart lies a magnetar, one of the universe's most violent and enigmatic objects, surrounded by 10 ordinary stars locked in its gravitational grip. This isn't just a star system, it's a cosmic pressure cooker where magnetic forces warp the very fabric of space around it. Magnetars are neutron stars on steroids, packing the mass of a sun into a city-sized sphere with magnetic fields a quadrillion times stronger than Earth. If this one were placed halfway between us and the Moon, its pull would erase the data on every credit card on the planet. Yet in this system, that unimaginable force isn't acting alone. It's tangling with the gravity of 10 other stars, creating a never-before-seen celestial tug-of-war. The effects are both dramatic and bizarre. The magnetar's crushing magnetic field whips charged particles from its stellar neighbors into frenzied spirals, generating bursts of X-rays so intense they briefly outshine the entire system. Some stars in its orbit show strange, synchronized flares like clockwork, their surfaces erupting in ultraviolet storms whenever the magnetar's magnetic tides stretch them too far. But the real puzzle is how this arrangement even exists. Magnetars typically form when massive stars collapse in supernova explosions violent enough to vaporize nearby companions. Yet here, 10 stars survived the blast, now trapped in orbits so close they're practically brushing against a celestial buzzsaw. Did they form together, defying the odds? Or was this magnetar a rogue traveler captured by the system's gravity long after its birth? Every observation peels back another layer of mystery. This system isn't just a laboratory for extreme physics, it's a reminder that the universe's rulebook still has pages we've yet to read. In the swirling chaos of undecuple star systems, astronomers have uncovered something even more astonishing. A gargantuan ring of dust and gas stretching so wide it encircles all 11 stars at once. This isn't just a planetary construction zone, it's a cosmic conveyor belt operating on a mind-boggling scale. The disk spans distances that dwarf our entire solar system, its edges shimmering with the faint glow of icy particles and nascent rubble. Normally, protoplanetary disks cling to single stars like the one that birthed Earth. But here, the disk defies logic by remaining intact despite the gravitational tug-of-war between 11 competing suns. One wrong move and the entire structure should have shredded into scattered debris eons ago. Yet somehow it persists, an engineering marvel written in gas and dust. The secret might lie in its sheer distance. Unlike tightly packed systems where stars jostle like commuters on a train, this disk orbits so far out that the star's combined gravity acts like a single anchor, smoothing out the violent tugs that would otherwise tear it apart. Think of it as a hula hoop spun around a cluster of dancers. The motion averages out, keeping the ring stable. But the real surprise, this disk might still be forming planets. Amid the turbulence, pockets of material could be clumping together in slow motion, building worlds that would orbit not one star, but the entire Undecuple family. Imagine a planet where the sky is filled with 11 suns, some rising while others set in an endless celestial choreography. Of course, the odds are stacked against these fledgling worlds. With so many gravitational bullies in the neighborhood, any budding planet risks being flung into deep space or ripped apart by tidal forces. Yet the mere existence of this disk proves that even in the most hostile environments, nature finds a way to lay the groundwork for new worlds. What does this mean for the search for life? If planets can form here, they'd exist in a twilight zone too far from any single star for warmth, yet possibly heated by constant gravitational flexing or reflected light from the disk itself. It's a scenario that stretches our imagination, forcing us to reconsider where and how life might take root in the universe. This discovery doesn't just add another oddity to the Undecuple catalog. It challenges our very definition of a planetary system, proving that when it comes to cosmic construction, the universe's blueprints are far more creative than we ever dreamed. One of the strangest residents in any Undecuple system isn't a black hole or a rogue planet. It's a star that refuses to act its age. Astronomers recently spotted a blue straggler, a blazing, youthful rebel shining defiantly among older, cooler siblings. This stellar oddity burns hotter and brighter than its family members, like a teenager crashing a retirement home party. The mystery here isn't just its energy, it's the sheer improbability of its existence. Blue stragglers typically form in densely packed globular clusters, where stars frequently collide and merge. But in an Undecuple system where gravitational chaos should rip stars apart rather than fuse them, this fiery outlier shouldn't have survived. Yet there it is, glowing with the vigor of a star half its age while its siblings fade into red giants. So how did this cosmic Benjamin Button cheat time? The leading theory is a dramatic stellar merger, two older stars tangling too close and combining into a single, rejuvenated powerhouse. Imagine two aging dancers colliding mid-step and emerging as one, suddenly moving with renewed energy. In this crowded system where stars whip around each other at dizzying speeds, close encounters could have sparked this explosive rebirth. But here's the twist: mergers in Undecuple systems should be catastrophic, often flinging stars out entirely. The fact that this blue straggler stayed suggests the system might have a hidden stabilizing force, perhaps an unseen black hole or a delicate orbital resonance keeping mergers contained. It's like watching a demolition derby where one car emerges not just intact but upgraded. This discovery forces us to rethink how stars evolve in extreme environments. If blue stragglers can form and survive amid such chaos, they might be more common in complex systems than we ever imagined, cosmic phoenixes rising from the gravitational fire. In the flickering heart of one extraordinary Undecuple system, astronomers found a celestial light show unlike anything seen before. All 11 stars pulse and dim in an ever-shifting symphony of brightness. These aren't just ordinary stars. Each one is a variable, swelling and shrinking in erratic yet strangely coordinated rhythms, turning the entire system into a cosmic disco ball. Variable stars are rare enough on their own. Most change brightness due to internal processes like a star's outer layers heaving in slow motion waves or sudden eruptions of magnetic activity. But finding an entire family of them locked in the same gravitational embrace, that's like stumbling upon a room full of synchronized fireflies, each flashing at its own tempo while somehow keeping the group's overall pattern intact. Deciphering this flickering chaos took years of patient observation. Some stars dim every few days like clockwork, while others erupt unpredictably, their light curves resembling jagged mountain ranges. A few even seem to respond to one another. When one star flares, another dims moments later, as if they're communicating through subtle gravitational nudges. The effect is mesmerizing, like watching a cosmic game of stellar telephone unfold across light years. The real puzzle is how such a delicate balance persists. Variable stars often have unstable outer layers, prone to shedding mass in violent bursts. Normally, that would destabilize their orbits over time, yet here, the system has endured for millions of years. One theory suggests tidal forces between the stars act like a regulatory hand, smoothing out their pulsations just enough to maintain harmony. Another possibility. These stars might all have formed from the same turbulent gas cloud, inheriting synchronized instability like siblings prone to the same nervous tics. This discovery isn't just a curiosity, it's a goldmine for astrophysics. By studying how these stars influence one another, scientists can probe the hidden mechanisms behind stellar variability in ways no lab could replicate. And every flicker of light carries a coded message about the secret rhythms of stars, the invisible threads of gravity, and the untold possibilities lurking in the galaxy's most crowded neighborhoods. If 11 variable stars can coexist in this fragile ballet, what other symphonies of light might be waiting undiscovered? The cosmos, it seems, still holds the sheet music to wonders we've only begun to imagine. Nestled inside a swirling nebula that glows like a cosmic watercolor painting lies an Undecuple star system unlike any other, where the stars don't just share orbits, they sculpt their very own interstellar masterpiece. This celestial family isn't merely living in a nebula, they're actively reshaping it, their fierce radiation and stellar winds carving intricate tunnels and cavities into the surrounding gas. And hidden within those glowing tendrils, a chemical fingerprint that reveals the star's deepest secrets. The nebula itself acts like a cosmic X-ray, its light filtered through the system's 11 stars. Each element leaves a distinct mark on the nebula's spectrum. Ionized oxygen glows blue-green, hydrogen paints the gas crimson, and traces of heavier metals like iron hint at violent stellar pasts. It's as if the stars are signing their names in elemental ink, giving astronomers a rare chance to study their composition without even peering directly at them. But the real spectacle is the feedback loop between the stars and their environment. The most massive members blast out ultraviolet radiation so intense it strips electrons from nearby gas atoms, lighting up the nebula like a neon sign. Meanwhile, the system's smaller stars contribute fierce stellar wind streams of charged particles that collide with the nebular material, sculpting it into towering pillars and delicate filaments. Some regions glow brighter where these forces clash, while others darken as denser pockets resist erosion, creating a celestial chiaroscuro effect. What's truly remarkable is how long this interplay has lasted. Most nebulae disperse within a few million years, blown away by the very stars they birthed. Yet here, the Undecuple system's gravity appears to be recycling the nebula, trapping ejected material in looping orbits where it eventually spirals back inward, fueling new generations of stars or even planets. It's a self-sustaining cosmic ecosystem, one that challenges our assumptions about how quickly stellar nurseries fade. This discovery does more than add another exotic system to the catalogue. It shows us that Undecuple stars aren't just passive residents of the universe, they're active architects, shaping their surroundings in ways that leave behind lasting chemical clues. And if we can decode those clues, we might finally understand what makes these stellar giants and the nebulas that cradle them tick. Amid the countless star systems drifting lazily through the galaxy, astronomers spotted something utterly bizarre, an Undecuple system barreling through space at breakneck speed, as if fleeing an invisible catastrophe. This isn't just a group of stars moving quickly, it's an entire 11-star family hurtling through the cosmos at nearly 800 kilometers per second, fast enough to cross the distance from Earth to the Moon in under 10 minutes. This runaway system didn't just pick up speed by chance. The leading theory, it was catapulted into motion by a close encounter with a supermassive black hole, possibly during a galactic collision billions of years ago. Imagine a game of cosmic pinball. This Undecuple wandered too close to the gravitational drain of a black hole, and rather than being swallowed, it received a slingshot kick so powerful it escaped its home galaxy entirely. Now it streaks through intergalactic space like a rogue comet, leaving a faint trail of disrupted gas in its wake. Tracking its trajectory was like reconstructing a crime scene. Astronomers mapped its path backward through the ages, accounting for gravitational tugs from nearby galaxies, and the clues pointed to a violent origin. The system's motion aligns eerily with the aftermath of a long-ago galactic merger, a chaotic event that could have hurled it into the void like a stone from a sling. What's even stranger is how the system's stars remain bound together despite this turbulence. Normally, such a gravitational kick should have torn them apart, scattering them across the cosmos. Yet here they are, clinging to one another with tenacious gravity, their delicate orbits surviving a journey that should have shattered them. Some researchers speculate their tight configuration might have acted like a shock absorber, distributing the forces evenly to avoid disruption. This discovery raises a thrilling possibility. If one Undecuple system can survive such an extreme ejection, how many others might be racing unnoticed through the darkness between galaxies? The universe, it seems, has a habit of flinging its most fragile treasures into the void, and some of them refuse to break. In the realm of celestial oddities, few discoveries blur the line between impossibility and reality like this one. An Undecuple star system not just hosting ordinary stars, but harboring 3 quasars locked in orbit around them. Quasars are among the most luminous objects in the universe, powered by supermassive black holes feeding on gas at the centers of distant galaxies. Yet here, 3 of these cosmic behemoths are somehow tethered to 8 stars, forming a hybrid system so bizarre it defies conventional astrophysics. The odds of this arrangement are staggeringly low. Quasars typically dominate their galactic cores, with gravity so overwhelming that nearby stars orbit them, not the other way around. Yet in this system, the roles are flipped. The quasars circle the stars like moths around a campfire. Astronomers suspect this inversion might be the result of a catastrophic galactic collision. Picture 2 or even 3 galaxies smashing together, their central black holes stripped of their stellar entourages and captured by the Undecuple system's gravity instead. Detecting this cosmic menagerie required piecing together clues across multiple wavelengths. The quasars' brilliant jets of X-rays and radio emissions stood out against the star's visible light, revealing their presence. But the real shock came when researchers realized the quasars weren't just passing through. They were bound to the system, their motions synchronized with the stars over vast orbital periods. What makes this discovery so groundbreaking is the sheer scale of forces at play. Quasars emit enough energy to vaporize entire solar systems, yet here their radiation appears oddly tempered, perhaps filtered by the system's dense interstellar gas or bent by the collective gravity of its stars. It's a cosmic balancing act on a knife's edge where the slightest shift could unleash havoc. Could this be a fleeting phenomenon, a snapshot of chaos before the quasars break free, or does it hint at a new class of hybrid systems waiting to be found? Either way, this Undecuple quasar mashup proves that when it comes to celestial mechanics, the universe still holds surprises that leave even the most seasoned astronomers speechless. Deep in the cosmic graveyard of our galaxy, astronomers have uncovered an Undecuple system unlike any other, one where all 11 stars have burned through their fuel and collapsed into dense, Earth-sized embers called white dwarfs. These stellar remnants glow faintly with leftover heat, like a celestial retirement home where every resident has reached the same final stage of life simultaneously. This discovery is extraordinary not just for its symmetry, but for what it tells us about stellar life cycles on an epic scale. White dwarfs typically form after stars like our Sun exhaust their nuclear fuel, shedding their outer layers and leaving behind a hot, compact core. But finding 11 in one system, all remarkably similar in age and composition, suggests this entire stellar family was born together and aged in lockstep, marching toward oblivion at the same cosmic pace. The implications are staggering. White dwarfs cool over billions of years, meaning this system is likely older than most structures in the galaxy. Yet despite their age, these ancient stars remain gravitationally bound, their orbits so finely tuned that not even the violent deaths of their former selves could tear them apart. Some researchers compare it to a synchronized sinking, like 11 ships going down at the same rate, their holes preserved in the icy depths of space. What's even more fascinating is the system's eventual fate. With no more fuel to burn, these white dwarfs will continue dimming until they become cold black dwarfs, a state so theoretical that none exist yet in the universe. But long before that, their mutual gravity may trigger a final act of cosmic recycling. If two white dwarfs spiral close enough, they could collide in a titanic explosion, forging heavier elements that might one day seed new stars or even planets. This ghostly Undecuple offers a rare glimpse into the far future of all star systems, a preview of how even the most crowded stellar neighborhoods might fade into darkness. And it begs a haunting question. If 11 stars can survive their deaths together, what other relics of the ancient cosmos are waiting to be found? Of all the bizarre objects hidden in the cosmos, few spark as much debate as the Thorn-Zitkow object, a theoretical stellar hybrid so strange it sounds like science fiction. Picture a red giant, a bloated aging star large enough to swallow planets, with a neutron star buried in its core like a cosmic Russian nesting doll. Now imagine this exotic pairing not floating alone in space, but tangled in the gravitational web of 10 other stars. That's exactly what astronomers might have found in one perplexing Undecuple system, if the detection holds up. The evidence comes in subtle, contradictory clues. Observations reveal a star with the telltale chemical fingerprint of a Thorn-Zitkow object, unusual concentrations of heavy elements like rubidium and lithium, which should have been cooked away by nuclear fusion long ago. These elements are thought to form in the extreme environment around a neutron star's surface, then get dredged up into the red giant's outer layers. But here's the catch. The system's other stars show gravitational perturbations that suggest something massive and compact is lurking nearby, yanking them off course in rhythmic tugs. Not everyone's convinced. Skeptics argue the chemical anomalies could come from a recent stellar collision or a swallowed planet. Others point out that a true Thorn-Zitkow object should emit faint X-rays from the neutron star's surface radiation that hasn't been detected yet. The debate hinges on a key question. Could a neutron star even survive inside a red giant's turbulent interior without being torn apart or sinking to the core? If confirmed, this system would rewrite stellar physics. The neutron star's gravity would churn the red giant's insides like a mixer, altering its lifespan and potentially triggering a supernova unlike any we've seen. Meanwhile, the other 10 stars would orbit this unstable duo at a precarious distance, their fates tied to a stellar time bomb. For now, this Undecuple system remains a celestial riddle, one that pushes the limits of what we think is possible. Whether it houses a genuine Thorn-Zitkow object or something even stranger, it proves that the universe still holds cosmic puzzles waiting to be solved. Discovery 20. The haunting Undecuple system with a zombie star. Imagine a star that should be dead, its explosive demise already written in the cosmic history books, but instead it lingers, a ghostly remnant refusing to fade away. In one eerie Undecuple system, astronomers found exactly that, a zombie star, a celestial survivor that somehow endured a supernova blast and now drifts among its siblings, warping their orbits with its erratic gravitational pull. This cosmic oddity wasn't supposed to exist. When massive stars die, they typically detonate in a supernova so violent that nothing remains except perhaps a black hole or neutron star. But this star defied the rules. Instead of vanishing, it left behind a mangled core, stripped of its outer layers but still flickering with unstable energy. Its glow pulses unpredictably, dimming and flaring like a dying ember reigniting itself over and over. The real mystery, how its presence distorts the entire system. The zombie star's gravity tugs on its 10 siblings in bizarre ways, causing them to zigzag erratically instead of following smooth orbits. Some stars accelerate suddenly as if shoved by an unseen hand, while others slow down mid-flight, their paths warped by the remnant's chaotic influence. It's like watching a cosmic game of musical chairs where one player keeps changing the tempo. Scientists suspect this star might be a supernova imposter, a rare type of explosion that doesn't fully destroy the star but leaves it in a grotesque half-dead state. Normally, such remnants are solitary, drifting alone through space. But here, the zombie star's Undecuple family amplifies its strangeness, turning its survival into a gravitational haunting. Could this be a preview of our own sun's fate, billions of years from now? Probably not, but it forces us to reconsider how stars die. If a supernova doesn't always mean the end, what other undead stars might be lurking in the cosmos, silently reshaping their stellar neighborhoods? The universe, it seems, has a flair for the dramatic, even in death. One of the most puzzling enigmas in modern astronomy just took an even stranger turn. Researchers have detected an Undecuple star system where the orbits literally don't add up. No matter how precisely scientists calculate the gravitational pull of its 11 stars, something invisible appears to be tugging at them, warping their paths in ways that defy conventional physics. The prime suspect, dark matter, the universe's most elusive ghost, caught in the act of shaping a stellar family right before our eyes. This cosmic detective story began when astronomers noticed subtle anomalies in the system's motions. Stars that should have been drifting apart were inexplicably clustered, while others accelerated suddenly, as if pulled by an unseen hand. At first, the team assumed their instruments were flawed or that hidden planets might be responsible. But after ruling out every conceivable explanation, from rogue black holes to debris clouds, only one possibility remained: a concentrated knot of dark matter, woven into the system's gravitational fabric like an invisible seam. Dark matter famously refuses to emit or absorb light, revealing itself only through its gravitational grip on visible objects. Normally, it's detected on galactic scales, subtly bending the paths of entire star clusters. But here, the effect is hyper-localized, a dense pocket of dark matter tangled among the stars, its presence inferred by the way it twists their orbits like an unseen puppeteer. Some researchers speculate this clump could be a remnant from the system's violent formation, a gravitational scar frozen in time. Others wonder if it's a rare mini-halo, a self-contained bubble of dark matter drifting through the galaxy like cosmic flotsam. Skeptics argue the anomalies might stem from overlooked complexities in the star's own interactions. With 11 massive bodies weaving through space, even tiny measurement errors could amplify into phantom signals. Yet the data persists, hinting at a shadowy architecture lurking just beyond our sight. If confirmed, this system could become a Rosetta Stone for decoding dark matter's behavior on scales smaller than ever observed, a laboratory for the invisible. What's at stake isn't just another oddity, it's a chance to glimpse the universe's hidden scaffolding in action. If dark matter can nestle inside star systems, how many other cosmic neighborhoods might it secretly govern? The answer could rewrite the rules of celestial mechanics, proving that even in the most crowded stellar families, the real puppet master might be one we've never seen. Discovery 22. The Undecuple system that's unraveling into a cosmic spiderweb. Picture a star so stretched by gravity that it no longer resembles a sphere, but a shimmering, thread-like filament torn between survival and disintegration. Now imagine 11 stars undergoing the same brutal transformation, their outer layers pulled into spiraling tendrils that weave through space like strands of a celestial spiderweb. This isn't science fiction, it's the reality of an Undecuple system caught in the throes of gravitational chaos. The phenomenon, known as tidal stretching, occurs when stars pass perilously close to one another or a massive object like a black hole. The difference in gravitational pull between the near and far sides of the star becomes so extreme that it stretches the star apart, leaving behind a luminous tail of stripped gas and plasma. Normally, this process is rare and fleeting, a brief cosmic tug of war before the star either escapes or is consumed. But in this system, all 11 stars show signs of tidal distortion, their elongated forms locked in a slow-motion dance of mutual destruction. What makes this undecuple arrangement so unstable isn't just the stretching, it's the feedback loop of chaos it creates. As each star's material is siphoned into these glowing tails, the lost mass weakens its gravitational hold on the others, altering orbits in unpredictable ways. Some tails stretch across billions of kilometers, brushing against neighboring stars and transferring momentum like celestial whips. Others spiral inward, forming a tangled web of gas that further complicates the system's dynamics. Over time, this could trigger a cascade of collisions or ejections, unraveling the entire stellar family strand by strand. Yet against all odds, the system persists for now. Researchers suspect the stars might be trapped in a temporary equilibrium, their mutual destruction slowed by the very tails that threaten them. Like a spiderweb trembling in the wind, the structure flexes but doesn't yet snap. The question is, how long can it last, and if this delicate balance fails, will the stars scatter into the void, or collapse into a single, monstrous merger? This discovery does more than add another oddity to the cosmic catalogue. It offers a front-row seat to stellar evolution at its most violent, a preview of how even the most tightly bound systems can come undone. And somewhere in that glowing spiderweb of stars, the universe is writing a lesson about fragility, force, and the invisible threads that hold it all together. Discovery 23, the cosmic firecracker, an undecuple system with a hyperactive flare star in the cosmic symphony of undecuple systems. One star stands out not for its size or brilliance but for its temper. Imagine a celestial tantrum so violent it outshines the combined light of its 10 siblings for brief, terrifying moments. Meet the system's resident flare star, a red dwarf so hyperactive it unleashes superflares hundreds of times more powerful than anything our sun has ever produced. These aren't just ordinary solar flares. Each eruption bombards the surrounding stars with enough X-rays and ultraviolet radiation to strip away atmospheres and sterilize planets within a staggering radius. If Earth orbited this star, a single superflare could fry our ozone layer in minutes, a stark reminder of how hostile some cosmic neighborhoods can be. What makes this flare star especially puzzling is its timing. Unlike the predictable cycles of most active stars, this one erupts at random, sometimes firing off multiple superflares in a day, then falling eerily silent for months. Astronomers suspect its erratic behavior might be fueled by the system's gravitational chaos. The constant tug of war between its 10 stellar siblings could be twisting its magnetic fields into knots, storing energy until snap, it explodes in a torrent of radiation. The fallout, a brutal environment for any potential planets. While some of the system's cooler stars orbit at a safer distance, worlds closer to the flare star face a grim fate. Their surfaces might be scoured clean by relentless particle storms, their atmospheres long since evaporated into space, yet even here there's a glimmer of possibility. Life, if it exists, could cling to subterranean niches or beneath icy shells, places where radiation can't reach. Strangely, this stellar tantrum might also have an upside. The same radiation that devastates nearby planets could trigger complex chemistry in distant gas giants' atmospheres, sparking reactions that might never occur in common systems. It's a reminder that in the cosmos, destruction and creation often go hand in hand. This hyperactive undecuple system doesn't just challenge our ideas about habitability, it forces us to reconsider where life might persist against the odds. If a planet can survive in the shadow of a cosmic flamethrower, what other extreme corners of the universe might harbor hidden survivors? Discovery 24. The undecuple system with a glitching pulsar. Most pulsars are the universe's most precise timekeepers, spinning with such predictable rhythm that their pulses could rival atomic clocks. But in one undecuple system, astronomers found something far stranger, a pulsar that stutters. Without warning, its spin speeds up or slows down in erratic bursts, as if some unseen force keeps pressing cosmic pause and fast forward. This pulsar isn't just malfunctioning, it's being toyed with by its 10 stellar siblings. Normally, these ultra-dense neutron stars rotate with near-perfect consistency, their beams of radiation sweeping across space like lighthouse beams. Yet here, gravitational tugs from the surrounding stars warp the pulsar's spin like a child jostling a spinning top. Every close pass or orbital resonance sends ripples through spacetime, twisting the pulsar's rotation without warning. The glitches themselves are a goldmine for astrophysics. Some last milliseconds barely detectable, others drag on for hours, the pulsar's entire rhythm thrown into disarray. One theory suggests the star's crust, a crystalline shell barely a kilometer thick, is cracking under the strain, its surface shifting abruptly like tectonic plates in fast motion. Another possibility, the system's chaotic orbits are funneling waves of dense gas onto the pulsar, adding weight that briefly alters its spin before being flung away. What's truly baffling is how the system remains stable despite this turbulence. Pulsars typically need serene environments to maintain their precision. Yet this one endures constant gravitational bullying, its rhythm disrupted but never fully broken. It's a testament to neutron stars' resilience and a reminder that even the universe's most rigid rules have exceptions. For researchers, this glitching pulsar is more than a curiosity, it's a natural laboratory for studying extreme physics. Every hiccup in its spin encodes data about the invisible forces at play, from the pulsar's internal structure to the hidden dance of its stellar neighbors. And if such chaos can exist here, how many other pulsars might be hiding similar secrets? The cosmos, it seems, still has a few tricks up its sleeve. Discovery 25, the Undecuple system wrapped in a cosmic knot at the furthest edges of theoretical physics, lies an idea so strange it bends the mind. Cosmic strings, hypothetical fractures in space-time so dense they could warp the fabric of reality itself. Now, astronomers may have stumbled upon an undecuple system caught in the pull of these invisible threads, its stars dancing to the tune of gravity's most elusive puppeteer. The evidence is subtle but unnerving. 11 stars orbit erratically, their paths kinked and twisted as if space itself were puckered around them. Some accelerate abruptly along perfectly straight lines, while others loop back on themselves in ways that defy conventional gravitational models. It's as if an unseen seam runs through the system, tugging stars like beads on an invisible wire. Cosmic strings, if they exist, would be relics of the early universe, infinitely thin yet unimaginably dense, carrying the weight of entire galaxies in a filament narrower than an atom. According to theory, anything crossing one would experience a gravitational snap, a sudden jolt in velocity without warning. That's precisely what appears to be happening here. Telescopes have caught stars mid-course correction, their trajectories shifting sharply, as if nudged by something beyond the laws of ordinary physics. Skeptics argue there are simpler explanations. Could hidden black holes or rogue dark matter clumps mimic these effects? Possibly, but no known object matches the precision of these distortions. The twists in space align too perfectly, like scratches on glass pointing unerringly in one direction. Even stranger, the system's oldest stars show older anomalies, their paths bent for longer, as if the strings have been there since the system's birth. If confirmed, this undecuple arrangement could be our first glimpse of a cosmic string's fingerprint, a ripple in space-time frozen in action. For physicists, it's a tantalizing clue to the universe's most enigmatic structures. For the rest of us, it's a reminder that the cosmos may be stitched together by forces we're only beginning to imagine. Whether these strings are real or just a quirk of gravity, one thing is certain: this system doesn't play by the usual rules. And somewhere in its tangled orbits, the universe might be whispering secrets about the very framework of existence. Discovery 26, the Undecuple meta-solar system where every star hosts a planet picture, a cosmic matryoshka doll. a nested marvel where each of 11 stars cradles its own orbiting world. Astronomers have uncovered an Undecuple system that isn't just a stellar oddity. It's a full-fledged meta-solar system with planets circling every single member like celestial clockwork. This discovery shatters expectations, proving that even in the most crowded stellar neighborhoods, planets can find a way to survive and thrive. The real puzzle isn't just the existence of these exoplanets, it's how they endure. Conventional wisdom says such a packed system should be a gravitational demolition derby, with planets flung into deep space or shredded by tidal forces. Yet here, each world orbits its host star with eerie stability, as if locked into some grand cosmic truce, the secret distance and rhythm. These planets cling to tight, close-in orbits, staying nestled near their stars like chicks under a mother's wing, far enough from the system's chaotic center to avoid catastrophic tugs from neighboring suns. But the true masterpiece is their synchronization. Observations suggest the planets move in resonant harmonies, their orbits timed so precisely that gravitational nudges from passing stars cancel out rather than disrupt. Imagine 11 metronomes ticking at different speeds, yet somehow never clashing, a feat of celestial engineering that defies randomness. Some worlds even share orbital periods in neat ratios, like a musical chord played across light years. Yet the system's real gift to science is its diversity. Gas giants orbit scorching blue stars, their atmospheres blistering under intense UV radiation. Ice-covered super-Earths circle dim red dwarfs, where faint sunlight barely reaches frozen surfaces. A few planets even straddle the line between stability and chaos, their orbits just precarious enough to hint at past collisions or near misses. This menagerie offers astrophysicists a one-stop laboratory to study how planets form and evolve under extremes no single star could replicate. Could any of these worlds harbor life? It's a tantalizing thought, though the constant glare and gravity of 11 suns would make survival a staggering challenge. But if there's one lesson this meta-solar system teaches, it's that the universe loves breaking its own rules. Where we once saw limits, nature paints possibilities, and in the dance of these 11 stars and their faithful planets, we catch a glimpse of just how inventive cosmic architecture can be. Discovery 27, the Undecuple system with a vampire star in the cosmic drama of crowded star systems. Few characters are as ruthless as the vampire star, a celestial predator that survives by feasting on its siblings. Nestled within one Undecuple family, astronomers have spotted a star literally stealing life from its neighbors, gorging on stolen gas until it shines unnaturally bright against the darkness of space. This stellar vampire doesn't hunt alone. The Undecuple environment elevates its feeding frenzy into a spectacle of gravitational theft. Normally, vampire stars, known as accreting binaries, operate in pairs where a denser star like a white dwarf or neutron star siphons material from a donor companion. But here, the presence of 10 other stars turns this process into a free-for-all. The vampire isn't just draining one star, it's exploiting the entire system's chaos, latching onto whichever sibling drifts too close. The mechanics are both brutal and mesmerizing. As gas from a victim star gets pulled away, it spirals into a glowing disk around the vampire, superheated to millions of degrees before plunging onto its surface in a torrent of X-rays and ultraviolet light. Each feeding session can last centuries, leaving the donor star dimmed and shrunken while the vampire bloats into an unnatural blue giant, a cosmic imposter glowing with borrowed energy. What makes this system especially bizarre is the role of the other stars. Their gravity constantly destabilizes the vampire's meals, yanking potential prey out of reach or shoving new donors into its path. At times, the feeding disk flickers erratically, its brightness surging as clumps of gas collide or spiral inward. It's like watching a buffet where the tables keep shaking. Every bite comes with a struggle. Yet for all its violence, this process might be key to the system's survival. By redistributing mass, the vampire star could actually prevent catastrophic collisions, acting as a gravitational pressure valve. Some theorists even suggest these feeding frenzies might extend the system's lifespan, delaying the moment when stars either merge or fling each other into the void. This discovery doesn't just add another oddity to the Undecuple catalog, it reveals how theft might be a hidden force shaping stellar evolution. If vampires can thrive in such chaos, how many other star systems are hiding similar predators, quietly rewriting their fates one stolen sunbeam at a time? Discovery 28. The ancient relic and Undecuple system wrapped in a fossilized debris disk. While most star systems wear their age gracefully, one Undecuple family wears its history like a scar, a vast, swirling disk of cosmic wreckage, the shattered remains of planets that almost were. This isn't just a debris field, it's a fossil record, a graveyard of planetary ambitions frozen in time. Stretching farther than our entire solar system, this disk glows faintly with the infrared echoes of countless collisions, a silent witness to the chaos of its youth. At first glance, it resembles our own Kuiper belt, the icy rubble at the edge of our solar system. But where the Kuiper belt is orderly, this disk is pandemonium. Chunks of rock and metal, some as large as dwarf planets, orbit in erratic loops, their paths twisted by the competing gravity of 11 stars. Some debris clumps into transient rings, only to be shattered again by a passing star's pull. Other fragments spiral inward, destined to be swallowed or vaporized by the system's blazing cores. It's a demolition derby on a cosmic scale where the wreckage never quite settles. What makes this disk so extraordinary isn't just its violence, it's its age. Spectroscopy reveals dust grains older than Earth itself, their chemistry altered by eons of radiation. These aren't just leftovers from recent crashes, they're artifacts of a time when this system might have harbored full-fledged planets before the star's gravitational tug of war tore them apart. Some researchers compare it to an archaeological dig, where each layer of debris tells a different chapter of the system's violent past, the real mystery. How the disk survives at all, with so many stars stirring the pot, conventional models predict the debris should have been ejected or consumed long ago. Yet here it lingers, a testament to some unseen equilibrium, perhaps shielded by resonant orbits or replenished by ongoing collisions. If so, this disk isn't just a relic, it's a living fossil, still growing and evolving even as we watch. For astronomers, it's a window into the untold stories of failed planets. If even this Undecuple maelstrom couldn't erase all traces of its past, what other forgotten histories might be hiding in the debris disks of quieter systems? The universe, it seems, keeps its receipts, and sometimes they're written in dust and ice. Discovery 29. The Undecuple system with a chameleon star in the cosmic menagerie of strange stars. Few are as elusive as the chameleon, a celestial shape-shifter that refuses to be pinned down. At the heart of one Undecuple system, astronomers have spotted a star that defies classification, flickering between spectral types like a cosmic impersonator. One moment it burns as a blue giant, its light scorching and intense. The next it cools abruptly into a red dwarf, its glow dimming to a faint ember, all without any logical trigger. This isn't just a star with mood swings. It's rewriting the rules of stellar identity in real time. Theories abound, but none fully explain the chameleon's act. Some researchers suspect violent magnetic upheavals could be scrambling its outer layers, altering the light it emits. Imagine a star with a restless interior, its magnetic fields tangling and snapping like rubber bands, reheating and cooling its surface in erratic bursts. Others propose a darker twist. An obscured companion, perhaps a black hole or neutron star, might orbit just out of sight, its gravity periodically siphoning material from the chameleon and distorting its appearance. Every time we think we've caught it in its true form, it slips into another disguise. What makes this star especially puzzling is how its changes ripple through the system. The other 10 stars react to its shifts, some brightening slightly when the chameleon dims, as if compensating for the loss of light. It's a delicate gravitational feedback loop, one that hints at unseen connections between the stellar siblings. Even more bizarre, the transitions don't follow a pattern. Unlike variable stars with predictable cycles, this one switches roles at random, leaving astronomers scrambling to explain each new phase. Could this be a glimpse into a previously unknown stage of stellar evolution, a turbulent adolescence where stars experiment with different identities before settling down? Or is it a cosmic fluke, a once-in-a-billion-years alignment of factors we've yet to understand? Whatever the answer, the chameleon star proves that even in the most crowded systems, individuality can still shine through in the most unpredictable ways. For now, this celestial enigma remains a reminder. The universe loves a good plot twist, and sometimes the most ordinary-looking stars are hiding the wildest secrets. Discovery 30. The Shadow Collective, an Undecuple system of failed stars. Forget blazing suns, this Undecuple system runs on cosmic leftovers. Instead of brilliant stars lighting up the void, all 11 members are brown dwarfs, the universe's ultimate underachievers. These celestial misfits never quite gathered enough mass to ignite full nuclear fusion, leaving them stuck in a perpetual twilight too big to be planets, but too small to shine like true stars. Imagine a sky dominated by 11 dim, ruddy embers, each radiating a faint infrared glow instead of visible light. Without the fierce energy of hydrogen fusion, brown dwarfs are essentially cooling corpses, their warmth coming from the slow crush of gravity compressing their cores over billions of years. Yet in this Undecuple arrangement, their collective heat creates an eerie ambience, like a room lit only by dying coals. The real surprise, these brown dwarfs defy expectations by sticking together. Conventional wisdom suggests such low-mass objects should have been easily scattered by passing stars or galactic tides, yet here they've clung to one another in a gravitational huddle for eons. Some even orbit so close they share atmospheres, their outer layers of hydrogen and helium mingling in a slow-motion stellar tango. What makes this system a goldmine for astronomers is its potential to rewrite the rules of star formation. Brown dwarfs typically form in isolation or sparse groups, making an 11-member cluster a statistical miracle. Some researchers speculate they were born in an unusually dense, cold gas cloud that fragmented just enough to spawn these quasi-stars but lacked the fuel to make true suns. Others wonder if they're the survivors of a larger system, their heavier siblings long since ejected or collapsed. For anyone dreaming of life in this shadowy realm, the prospects are bleak but not impossible. While these brown dwarfs emit no sunlight, their residual heat could theoretically warm distant moons, creating subsurface havens where liquid water might persist. It's a haunting thought, an entire civilization evolving in perpetual dusk, their sky dotted not with stars but with the faint, smoldering orbs of failed suns. This discovery doesn't just add another oddity to the catalogue, it challenges our definitions of what a star system is. If 11 dim, nearly invisible objects can bind together against the odds, how many other shadowy collectives might be lurking unseen in the cosmic dark? The universe, it seems, has a flair for the subtle as much as the spectacular. Discovery 31. The Phantom Star, an Undecuple system with a ghost orbit, a cosmic whodunit. It is unfolding in one Undecuple system, where astronomers have found something deeply unsettling, an orbit that shouldn't be empty. Like a chair pulled away at the last second at a celestial dinner table, this path in space is disturbingly vacant, yet everything around it behaves as if something massive is still sitting there. The gravitational fingerprints are unmistakable. The remaining 10 stars sway and wobble, responding to an invisible force that should belong to an 11th star. But where is it? This isn't just a case of a missing star, it's a gravitational ghost story. The disturbance in the system's dynamics suggests an object hefty enough to leave a gravitational scar, yet scopes reveal nothing but empty space along its projected path. One explanation, a catastrophic exit. The missing star might have been violently ejected, flung into the void by a close encounter with its siblings. Simulations show that in systems this crowded, gravitational slingshots can hurl stars away at speeds that defy escape velocity, leaving behind only ripples in the orbits of those left behind. Another possibility is even stranger. What if the star didn't flee but collapsed? If the 11th member was a massive, unstable giant, it could have imploded into a black hole without the telltale fireworks of a supernova. Unlike explosive deaths that fling debris outward, a direct collapse would leave no visible trace, just a dark remnant lurking unseen, its presence betrayed only by the way it tugs on its neighbors. The most chilling clue comes from the system's youngest stars. Their orbits bear fresh gravitational scars, suggesting this disappearance might be a recent event in cosmic terms, perhaps within the last few million years. If so, the system could still be reeling from the loss, its delicate balance thrown into disarray as the remaining stars adjust to the sudden void. For astronomers, this ghost orbit is more than a celestial mystery. It's a rare chance to study the aftermath of stellar vanishing acts. Whether the missing star was exiled or consumed, its absence rewrites the rules of how these crowded systems evolve. And if Undecuple arrangements can hide such dramatic departures, how many other star clusters are keeping secrets of their own? The universe, it seems, has a habit of erasing its tracks, but gravity never forgets. Discovery 32. The cosmic clock, an Undecuple system with a time crystal star timekeeping in the universe, usually relies on predictable, rhythmic phenomena, pulsars spinning like hyper-accurate metronomes, or variable stars dimming and brightening on set schedules. But in one Undecuple system, astronomers may have found something even stranger, a star whose pulsations are so unnaturally precise, they resemble a time crystal, a theoretical structure that repeats not just in space but in time itself. At the heart of this system, one star pulses with a regularity that borders on mechanical. Every flare, every flicker, follows an exact sequence like a drumbeat so perfect it defies the natural chaos of stellar physics. Most stars show slight irregularities due to turbulence in their plasma or magnetic upheavals, yet this one behaves almost artificially, as if guided by some hidden cosmic metronome. The comparison to time crystals, a mind-bending concept from quantum physics, isn't perfect. True time crystals are hypothetical structures that exhibit periodic motion without energy input, essentially breaking the symmetry of time. Stars, of course, do burn energy, but the eerie precision of this star's pulsations has researchers asking, could extreme gravitational interactions in the Undecuple system be forcing it into a hyper-stable rhythm? Critics argue the analogy stretches the science. Stellar pulsations, no matter how precise, still rely on internal processes like fusion-driven pressure waves. Yet even skeptics admit there's something uncanny here. The star cycles lock into the orbits of its 10 siblings with near mathematical perfection, as if the entire system is acting as a synchronized clock. Some theorize tidal forces from neighboring stars might be tuning its pulsations, like a pianist adjusting a string to resonate with another instrument. The implications are tantalizing. If stellar behavior can be engineered this precisely by external forces, it could reshape how we study variable stars in crowded systems. And if nature can mimic a time crystal's order without breaking physics, what other illusions of perfection might be hiding in the cosmos? For now, this stellar chronometer remains a beautiful oddity, one that challenges where we draw the line between natural chaos and cosmic order. Whether a true time crystal analog or just a marvel of gravitational choreography, it proves that even in the messiest stellar families, the universe occasionally keeps perfect time. Discovery 33. The Mirror Star, an Undecuple system's cosmic anomaly in the far reaches of the cosmos. Astronomers have spotted a star that doesn't belong, not because it's out of place, but because its very composition defies the rules. Nestled among 10 perfectly ordinary siblings, this celestial rebel boasts elemental ratios so bizarre they've sparked a debate. Could it be a visitor from a parallel universe? At first glance, the star seems unremarkable, just another member of its Undecuple family. But spectroscopic analysis revealed something unsettling. Key elements like lithium, europium, and even gold appear in ratios that contradict everything we know about stellar nucleosynthesis, the process by which stars forge atoms in their cores. In our universe, these elements follow predictable patterns based on a star's age and mass. Yet here, the numbers are flipped, as if the star cooked its ingredients using a recipe written in reverse. The wildest theory, this might be a mirror matter star, a relic from a hypothetical parallel cosmos where physics operates slightly differently. In such a universe, fundamental forces could rearrange how elements form, leaving behind a chemical fingerprint alien to our own. It's a tantalizing idea, but before we rewrite physics, there are simpler explanations. One leading hypothesis points to a violent past. The star might have once orbited a supernova, its outer layers polluted by fallout rich in rare isotopes. Another possibility, it's the survivor of a stellar collision, its atmosphere mixed with debris from a long-dead companion. Even cosmic dust, enriched by ancient neutron star mergers, could have altered its chemistry over billions of years. Yet the mystery lingers. If stellar contamination is the answer, why don't its siblings show similar anomalies? And why do the odd ratios persist so evenly throughout the star's layers rather than fading with time? For now, this mirror star remains a cosmic Rorschach test, revealing as much about our curiosity as it does about the universe's secrets. Whether a window into another reality or just a freak of stellar chemistry, one thing's clear: this Undecuple system isn't done surprising us. And somewhere in its tangled orbits, the line between science and speculation blurs, just enough to keep us wondering. Discovery 34. The Undecuple system, with 11 Tatooine worlds science fiction, became reality when astronomers discovered an Undecuple system where every single planet orbits multiple stars at once, just like Luke Skywalker's homeworld, Tatooine. But this isn't just one desert world with twin suns. It's 11 planets, each bathed in the shifting light of their own intricate stellar dance. The real wonder isn't just their existence, it's how they defy chaos to cling to stable orbits in such a gravitational circus. For a planet to survive here, it must navigate a cosmic tightrope. With 11 stars pulling at it from different directions, you'd expect these worlds to be yanked apart or flung into the void. Yet remarkably, many have settled into what scientists call resonant orbits, precise, repeating paths where the gravitational tugs from multiple stars cancel each other out. Imagine a planet threading between swinging pendulums, timing its steps so precisely that it never gets hit. That's the delicate choreography keeping these worlds intact. Some planets orbit pairs of stars locked in a close embrace, their double sunrises painting the skies in ever-changing hues. Others trace wide, slow loops around 3 or even 4 stars, their years stretching longer than Earth's history. One particularly resilient world weaves through a labyrinth of gravitational fields, passing so close to different stars that its seasons change unpredictably, blistering heat one century, frozen silence the next. The secret to their survival, distance and rhythm. Many of these planets orbit far enough from the stellar chaos that the stars' combined gravity acts like a single anchor, smoothing out the violent tugs. Others move in sync with their host stars' orbits, like a surfer riding the same wave indefinitely. A few might even owe their stability to sheer luck, having formed in just the right pocket of calm amid the storm. But the real question is, could any of these worlds harbor life? It's a long shot. The constant shifts in temperature and radiation would make Earth-like biology nearly impossible. Yet life as we know it thrives on extremes, perhaps deep underground or beneath icy shells, shielded from the celestial fireworks above. something clings to existence in the shadows of 11 suns. This discovery doesn't just expand our catalogue of exoplanets, it shatters the limits of where we thought they could exist. If planets can endure this stellar madness, how many other impossible orbits might be hiding in the cosmos? The universe, it seems, loves proving that even the wildest fiction can pale beside reality. Discovery 35. The impossible core, an undecuple system hiding a quark star tucked within the gravitational whirlwind of this 11-star family, lies something even more extraordinary, a stellar oddity so dense it straddles the line between reality and theory. Meet the system's elusive anchor, a candidate quark star, a hypothetical cosmic object that could rewrite the textbook on how matter behaves under extreme pressure. Unlike neutron stars, the collapsed remnants we're familiar with quark stars take density to another level. Picture a neutron star crushed further, its protons and neutrons shattered into their fundamental building blocks, a soup of free-roaming quarks. The result, an object packing the mass of a sun into a sphere smaller than Manhattan, with gravity so intense it bends the very rules of particle physics. The evidence here is indirect but tantalizing. One star in the system emits pulses of X-rays too regular for a neutron star, yet its temperature and luminosity defy typical models. Its surface gravity, inferred from light distortions, suggests a compactness beyond what neutron matter should allow. Some researchers argue these anomalies point to a quark core, a state of matter so extreme it's never been definitively observed in nature. Not everyone's convinced. Skeptics suggest overlapping neutron stars or accretion effects could mimic the signals. After all, quark matter remains theoretical. Even lab experiments can't yet recreate the pressures needed to confirm its existence. Yet if proven, this star would become a Rosetta Stone for understanding the universe's most unyielding state of matter, where gravity overcomes even the forces binding atomic nuclei. What makes this undecuple system uniquely suited to harbor such an oddity? The chaos might be the key. Gravitational interactions between the 11 stars could have compressed the candidate during a near collision or merger, pushing it over the neutron star limit. Alternatively, it might have formed this way, a cosmic fluke born from a nebula laced with exotic particles. For now, this stellar enigma remains a what-if at the frontier of astrophysics. But its very possibility reminds us that the universe doesn't just challenge our expectations, it demolishes them, one ultra-dense mystery at a time. Discovery 36. The stellar Frankenstein, a cosmic patchwork of the dead in a universe where stars usually live and die by predictable rules. Astronomers have stumbled upon a cosmic abomination, a star that shouldn't exist. This celestial Frankenstein isn't just a single, coherent object. It's a grotesque mashup of stellar corpses, stitched together from the shattered remains of long-dead suns. At first glance, it appears as just another star in its undecuple family until you peer into its spectral fingerprints. The chemistry is all wrong. Layers of its atmosphere bear elements that never coexist naturally in a single star. Pockets of helium fused in ancient red giants, traces of carbon forged in white dwarf explosions, even rare metals like gold and uranium materials that only form in the heart of supernova or neutron star collisions. It's as if this star raided a graveyard of stellar relics and wore them like a macabre trophy. The leading theory, a series of violent mergers, stellar cannibalism on a scale we've never seen. Picture two aging stars spiraling too close, colliding in a fiery embrace. Normally, such an event would trigger a cataclysmic explosion, scattering debris into space. But in this case, something went different. The stars fused instead of detonating, their remains knitting together into a single, unstable monstrosity. And somehow, this star didn't stop at one merger. Over millennia, it may have absorbed multiple others, each collision grafting new layers of foreign material onto its surface. What's truly unsettling is how it behaves. Unlike normal stars that burn steadily, this one flickers erratically. its light tainted by chemical imbalances deep within. Some layers bubble violently, ejecting globs of half-fused plasma, while others remain eerily stagnant, like dead weight dragging the star down. It's a star fighting its own identity, neither fully alive nor completely dead. Yet, against all odds, the Undecuple system tolerates this misfit. The other 10 stars orbit cautiously, as if giving the Frankenstein star a wide berth. Perhaps they sense its instability, that one day it might erupt in a final, catastrophic spasm, scattering its patchwork remains across the system. Or maybe, just maybe, this stellar patchwork is a preview of a new kind of celestial evolution, one where stars don't just die but reassemble into something stranger. For astronomers, this freak of nature is a gold mine. It's proof that the universe isn't done inventing ways to surprise us, and that sometimes the most terrifying discoveries are the ones that defy every rule we thought we knew. Discovery 37. The Shadow Sun, an Undecuple system's invisible giant somewhere in the cosmic tapestry. An Undecuple system hides a secret so dark, it challenges everything we know about stars. Amid its 11 members, one stands apart, not by shining brighter, but by not shining at all. This isn't a black hole, it isn't a dead stellar remnant. It's something far stranger, a dark star, a celestial phantom that emits no light, no heat, yet bends the orbits of its siblings with undeniable gravitational might. Unlike black holes, which devour light entirely, this enigmatic object appears to be a living star that somehow bypassed the usual fusion process. Imagine a failed sun, a vast sphere of hydrogen and helium that never ignited, its core too cool or too odd to spark nuclear reactions. No fiery surface, no solar flares, just an invisible titan lurking in the void, detectable only by the way it tugs on the 10 visible stars around it. The clues lie in the system's choreography. The orbits of the other stars warp unpredictably, as if an unseen hand is nudging them off course. Some accelerate abruptly when passing a seemingly empty patch of space, while others loop around nothing as if held by an invisible tether. Even stranger, the dark star's mass estimates suggest it should be bright, if it followed the usual stellar rules, yet telescopes see nothing, not a flicker. Not a whisper of radiation. Could this be a rogue dark matter object, a knot of exotic particles masquerading as a star, or a relic from the early universe, a primordial giant that formed under different physical laws? Some theorists propose even wilder ideas, like a cue ball, a hypothetical stellar oddity made of supersymmetric particles that repel light entirely. The implications are mind-bending. If dark stars exist, they'd rewrite the book on stellar evolution, proving that not all massive objects in space need to glow. They might even solve cosmic mysteries, like the identity of some dark matter hiding in plain sight. For now, this Undecuple system keeps its secrets close, but one thing's certain: in a universe full of light, the darkest objects might be the ones teaching us the most. Discovery 38. The Dark Ballet, an Undecuple system of wandering black holes. Imagine a star system where not a single sun shines, where darkness reigns, and gravity is the only ruler. Now take that terrifying vision one step further. 11 black holes drifting silently through the void, bound together in an intricate dance of pure annihilation. This isn't science fiction. It's a hypothetical nightmare scenario that pushes the laws of physics to their absolute limit. Unlike traditional star systems where light and heat dominate, this cosmic family operates in eerie silence. Each black hole, some mere shadows of collapsed stars, others monstrous giants, tugs on the others with invisible strings of gravity, weaving a tapestry of warped space-time. Their orbits aren't like the predictable paths of stars. They're chaotic, spiraling close enough to bend light into grotesque loops before flinging each other away in slingshot maneuvers. What's truly baffling is how such a system could even form. Normally, black holes are the end game of massive stars, born in violent supernova that should blast their siblings apart. But somehow, in this hypothetical scenario, 11 of them ended up trapped in the same gravitational web. One theory suggests they were once part of a dense stellar cluster, their parent stars dying in rapid succession, leaving behind a graveyard of remnants too close to escape one another. Another possibility, a long-ago galactic collision funneled rogue black holes into a shared orbit like moths trapped in a cosmic spider's web. The dynamics here rewrite the rules of orbital mechanics. With no light to reveal their presence, the black holes betray themselves only through subtle ripples, gravitational waves, emitted when they pass too close, warping space-time like pebbles dropped in a pond. Some might spiral inward over eons, destined to collide in bursts of energy so immense they'd outshine entire galaxies. Others could be flung into the void, ejected by the very forces that once bound them. Yet the most unsettling question isn't how they move, it's what happens in the spaces between them. In a normal system, planets might form in the gaps. Here, there's only a crushing emptiness where even stray gas or dust would be shredded by tidal forces long before it could coalesce. It's a system utterly barren of life, light, or warmth, a cosmic void where gravity alone holds court. If such a dark family exists, it would challenge our understanding of how black holes interact on galactic scales. Are they destined to devour one another? Or does their dance continue indefinitely, a shadow play hidden in the depths of space? The universe has already shown us how strange it can be, but this would be its most haunting performance yet. Discovery 39, the quantum star when cosmic scale meets quantum weirdness at the heart of one Undecuple system. A star behaves less like a celestial object and more like a particle in a lab experiment. This isn't just a star, it's a cosmic Schrödinger's cat existing in a state so bizarre it blurs the line between the quantum realm and the astronomical. Under the crushing gravity of its 10 siblings, this star seems to defy location itself, flickering between measurable states as if uncertain where, or even when, it truly is. Quantum effects aren't supposed to play out on stellar scales. At the subatomic level, particles can exist in superposition, occupying multiple positions or states until observed. But stars, they're too massive, their gravity too dominant for such delicate quantum rules to apply, or so we thought. This star's erratic behavior, its luminosity shifting unpredictably, its spectral lines splitting into ghostly duplicates suggests something unprecedented. Quantum physics writ large across an object millions of kilometers wide. Scientists first noticed the anomaly in flickering X-ray emissions. Unlike typical variable stars whose pulses follow physical processes like fusion cycles or magnetic flares, this star's fluctuations had no rhythm. Instruments would detect it pulsating in one spot, only for follow-up observations to find it dimmer or brighter or slightly displaced, as if it had briefly tried out another position before snapping back. The data pointed to a chilling possibility. Under the system's extreme gravitational forces, the star's own matter might be hovering in quantum uncertainty, its atoms tugged between competing realities. Of course, skepticism runs deep. Mainstream physics insists quantum behavior can't scale up this dramatically, yet the evidence lingers like a cosmic riddle. Some theorists propose a loophole. The star could be caught in a gravitational sweet spot, where tidal forces from its 10 neighbors cancel out just enough to isolate pockets of quantum effects in its core. Others wonder if we're seeing not the star itself, but its light bent through warped space-time, creating an illusion of quantum weirdness. The implications are staggering. If quantum superposition can manifest on stellar scales, it might rewrite our understanding of how matter behaves under extreme gravity, with ripple effects for black holes, dark matter, even the birth of universes. But for now, this star remains a tantalizing outlier, daring us to question whether the universe's smallest rules might sometimes dictate its grandest phenomena. One thing's certain, in the quantum Undecuple system, reality itself seems up for debate. Discovery 40, The cosmic mirror, an Undecuple system with stellar echoes picture shouting into a cavern and hearing your voice bounce back seconds later. But instead of sound, imagine light ricocheting between stars, carrying whispers of explosions that tore through this system millions of years ago. That's precisely what astronomers have uncovered in one Undecuple arrangement, a celestial echo chamber where supernova from the distant past still flicker faintly among its 11 stars, replaying their violent deaths like ghosts trapped in a cosmic hall of mirrors. These aren't ordinary reflections. When a dying star explodes, its light surges outward in all directions, but in this crowded system, some of that light doesn't escape. Instead, it slams into thick clouds of dust and gas lingering between the stars, scattering and rebounding in eerie, delayed flashes. The result, a phenomenon called light echoes, illusory apparitions of long-dead supernova that appear to flare up again centuries or even millennia after the original blast, their light taking detours through the system's tangled architecture before finally reaching us. The most mesmerizing part, these echoes aren't just random flickers, they're a timeline of chaos. By analyzing the light's wavelength and intensity, researchers have reconstructed at least 3 distinct supernovae that rocked this system over the past 100,000 years. Each echo carries a chemical fingerprint, revealing how these explosions poisoned the system with heavy metals like gold and uranium, which were later woven into the atmospheres of the surviving stars. It's forensic astronomy at its finest. The light itself becomes a crime scene, telling us not just how these stars died, but how their deaths reshaped the system forever. Yet the echoes also pose a riddle. How did the Undecuple survive such relentless violence? Normally, repeated supernova would shred a star cluster apart, yet these 11 stars cling together like survivors of a shipwreck. Some theorists suggest their orbits are just loose enough to absorb the shockwaves without unraveling, while others wonder if dark matter or an unseen black hole acts as a gravitational anchor, steadying the system against the storms. For now, this stellar echo chamber offers something rare, a window into the past that most cosmic structures erase. As telescopes capture more of these ghostly flashes, we're not just watching light, we're seeing time itself bend around these stars, proving that even in the vastness of space, nothing ever truly disappears. It just waits silently for us to listen. Discovery 41, the cosmic menagerie, an Undecuple system with a stellar zoo. Most star systems are monotonous neighborhoods. A few stars of similar size and color, maybe a rogue outlier if you're lucky. But in this Undecuple family, the universe went wild with variety. Imagine a celestial zoo where every cage holds a different species of star, blazing blue O-types, golden G-types like our sun, and dim red M dwarfs so cool they'd struggle to melt ice. Together, they form a living catalog of stellar evolution, a snapshot of the cosmos's boundless creativity. What makes this system extraordinary isn't just the diversity, it's the sheer improbability of their coexistence. Hot O-type stars burn fast and die young, often exploding before smaller stars even settle into middle age. Yet here, they orbit alongside ancient red dwarfs that will outlive the universe itself. It's like finding a kindergarten class sharing a playground with centenarians, their lifespan stretched across billions of years but bound by the same gravitational threads. The secret might lie in their choreography. Unlike chaotic Undecuple systems where stars jostle like bumper cars, this one has tiers, a gravitational hierarchy keeping the most violent members at a safe distance. The hottest stars dominate the inner orbits, while cooler, longer-lived stars settle into wider, calmer paths. Some even suspect this arrangement wasn't accidental. Perhaps the system formed from multiple gas clouds with wildly different compositions, each birthing stars on opposite ends of the spectrum. For astronomers, this stellar menagerie is a dream laboratory. By studying how these stars interact, we can witness cosmic processes that normally take eons to unfold, like watching a time lapse of stellar life and death compressed into a single system. Blue giants flood their smaller siblings with ultraviolet radiation, stripping away atmospheres or triggering unexpected chemistry in nearby gas clouds. Meanwhile, red dwarfs might host hidden planets, their surfaces bathed in the glow of neighboring suns like perpetual twilight. Yet the most tantalizing question isn't how they coexist, it's why. Did some cataclysm trap these stars together, or is this a rare glimpse of nature's flair for juxtaposition? Whatever the answer, this system reminds us that the cosmos thrives on contrast, painting its grandest masterpieces not in uniformity, but in dazzling, unpredictable variety. After all, if stars this different can share a cosmic home, what other impossible alliances might be waiting in the dark? Discovery 42. The boomerang star, a cosmic fugitive that couldn't escape. Most runaway stars blaze a one-way trail into the void, never to return. But in this Undecuple system, astronomers have witnessed something unprecedented, a star that was violently ejected, only to loop back into the gravitational fray like a celestial boomerang. This isn't just a stellar exile, it's a cosmic homecoming millions of years in the making. The evidence lies in the star's trajectory, a stretched parabolic arc across the sky with velocity readings revealing a staggering story. Roughly 500,000 years ago, gravitational chaos near the system's core hurled this star outward at nearly 2 million kilometers per hour. By all rights, it should have vanished into interstellar space. Yet here's the twist: as it raced away, the combined gravity of its 10 siblings curved its path, slowly reversing its course until it began falling back toward the system. Now it's completing its loop, a fugitive dragged home by invisible strings. What makes this boomerang effect possible? The answer lies in the system's unique gravitational well. Unlike simpler star clusters, the Undecuple's overlapping pulls create a sort of cosmic safety net. When the star was ejected, it didn't just escape the grasp of one or two stars, it had to overcome the collective tug of 10. That shared gravity acted like a stretched rubber band, eventually snapping the star back toward the chaos it tried to flee. But the real surprise is how the star's return is reshaping the system. Its incoming path is destabilizing other orbits, nudging stars into tighter spirals or wider ellipses. Some researchers compare it to tossing a boulder into a pond. The ripples will reverberate for millennia. Meanwhile, the boomerang star itself bears scars from its journey. Its outer layers were stripped by interstellar winds, leaving it smaller and dimmer than when it left. This discovery forces us to rethink how star systems evolve. Ejections aren't always endings, sometimes they're just dramatic pauses in a much longer dance. And if one Undecuple system can reel a star back in, how many other cosmic boomerangs might be arcing unseen through the galaxy, waiting for their moment to return? The universe, it seems, has a way of calling its wanderers home whether they like it or not. Discovery 43. The cosmic chatroom, an Undecuple system with a stellar internet in the bustling heart of this 11-star family. Something extraordinary is happening. Flares erupt, pulses quicken, and signals flicker between stars like cosmic Morse code. At first glance, it looks almost intentional, as if these stars are talking to one another. While the idea of stellar conversations might sound like science fiction, the reality is even stranger, a natural, synchronized light show that pushes the boundaries of what we thought stars could do. The phenomenon begins with a flare, a violent burst of radiation from one star. Moments later, another star answers with its own flash, perfectly timed. Then another and another. Like dominoes falling in slow motion, the entire Undecuple system lights up in a rhythmic cascade, each eruption triggering the next. It's not actual communication, of course. Stars don't talk, but the precision is uncanny, mimicking something far more deliberate than random astrophysics. So how does this celestial telegraph work? The answer lies in magnetic entanglement. These stars orbit so closely that their magnetic fields intertwine like knotted ropes. When one star's field destabilizes due to a flare or internal upheaval, the disturbance ripples through the connected web, jolting neighboring stars into action. Imagine yanking a spider's web and watching every strand tremble in response. That's the invisible force choreographing this dance, but there's another layer: gravity. As stars whip around one another, their tidal forces stretch and compress their interiors, building pressure until snap, a flare erupts. The timing isn't random, it's dictated by their orbits. Like gears in a clock, their motions align just right to create this illusion of dialogue. Some researchers compare it to pendulum clocks placed on the same wall eventually. Their swings synchronize not by design but by sheer physical coupling. Skeptics argue it's all coincidence, a statistical fluke in a system this chaotic. Yet the data leans toward something more structured. The flares don't just follow predictable intervals, they often mirror one another in energy and duration, as if the stars are locked in a feedback loop. Could there be an unknown mechanism amplifying these connections? Or is this simply a quirk of extreme gravitational environments we've never before witnessed at scale? One thing's certain, this stellar internet reveals how deeply interconnected these systems truly are. Even without sentience, stars in close quarters can create patterns so intricate they fool us into seeing intention where none exists. And if this Undecuple system can mimic communication, what other cosmic illusions might be hiding in plain sight? The universe, it seems, has a flair for dramatics, no language required. Discovery 44. The rule-breakers, an Undecuple system where stars defy physics. Most stars play by the rules, burning at predictable rates, shining with expected brightness based on their size and composition. But in this Undecuple system, the stars didn't just bend the rules, they tore them to shreds. 11 celestial rebels burn brighter, denser, and hotter than any model says they should, forcing astronomers to question whether we've misunderstood stellar physics all along. Take the most brazen offender, a star with the mass of a humble red dwarf, yet glowing as fiercely as a blue giant. By all known laws, this object shouldn't exist. Stars of this size simply lack the internal pressure to sustain such extreme fusion rates. Yet there it is, radiating enough energy to vaporize nearby planets, its core burning with a ferocity that defies every equation in the astrophysics playbook. Then there's its polar opposite, a star so massive it should have collapsed into a black hole eons ago, yet somehow remains stable, its outer layers pulsating gently like a sleeping beast. Theory says stars this heavy live fast and die young, their cores succumbing to gravity's grip within a few million years. But this one lingers, a cosmic paradox burning steadily as if time itself hesitates to claim it. The implications are seismic. If stars can bypass mass, luminosity limits the fundamental relationship governing how bright a star should be based on its size. It means entire chapters of stellar evolution need rewriting. Some researchers speculate these anomalies might stem from exotic matter in their cores, particles beyond our standard model altering fusion rates. Others wonder if the system's gravitational chaos acts like a pressure cooker, squeezing stars into unnatural efficiency. For now, these 11 misfits stand as a cosmic middle finger to textbooks, challenging us to explain their defiance. Are they freaks of nature or hints of deeper, undiscovered stellar laws? Every flicker of their impossible light forces us to reconsider, how much do we really know about how stars work? One thing's certain, the universe reserves the right to surprise us, and sometimes its greatest lessons come from the rebels who refuse to conform. Discovery 45. The cosmic ripple, an Undecuple system humming with hidden giants. Something invisible is stirring in this Undecuple system. An unseen force sending ripples through the very fabric of space-time itself. Astronomers tuning into the cosmos have detected faint but unmistakable gravitational waves emanating from this 11-star family, the telltale signature of colossal objects moving in ways we can't directly see. It's like hearing footsteps in a dark room. You know something massive is there, even if your eyes can't find it. Gravitational waves are cosmic vibrations ripples generated when massive objects accelerate, merge, or orbit one another. Normally, they come from cataclysmic events like colliding black holes, but here, the waves hum at a lower, steadier frequency, more like a sustained cello note than a drumbeat. The reason this system isn't just hosting stars, it's hiding something else, objects so dense and massive, their gravity warps space enough to send tremors across the galaxy. The prime suspect, a pair of supermassive black holes lurking in the system's shadowy periphery. They're danced so tight and fast that they churn the space around them like a blender. Another possibility is a cluster of neutron stars orbiting in eerie sync, their combined gravity twisting spacetime into knots. Or most intriguingly, there could be a primordial black hole, a hypothetical relic from the Big Bang itself, threading through the system like a ghost. What's truly fascinating is how these hidden giants shape the stars we can see. The 11 visible members don't move in smooth arcs. They stutter, accelerating and decelerating as if tugged by unseen hands. Some trace loopy, pretzel-like paths, their orbits warped by whatever lurks in the dark. Others flicker periodically, their light bent by gravitational lensing as invisible masses pass between them and us. For scientists, this system is more than a curiosity. It's a rare chance to study gravitational waves in context. By matching the ripple patterns to the visible star's motions, they can reverse engineer the system's hidden architecture, mapping the unseen just by watching how the scene reacts. It's cosmic detective work at its finest, where even empty space can betray its secrets. And if Undecuple systems can hide monsters like this, what else might be out there, quietly bending the universe to their will, waiting for us to listen? Discovery 46. The celestial rainbow, an Undecuple system painted in starlight. Most star systems shimmer in shades of gold, blue, or red, but in this corner of the cosmos, nature has crafted something far more vibrant. Imagine a stellar family where each member shines in a radically different hue, blazing violet, emerald green, even deep ultraviolet, like a celestial painter's palette scattered across the void. This isn't just a cosmic coincidence, it's a rare interplay of physics, chemistry, and sheer stellar spectacle. The secret lies in their temperatures and their atmospheres. While most stars' colors are dictated by heat alone, blue for scorching, red for cool, this system's stars defy the usual spectrum. One burns so fiercely with ultraviolet radiation that it appears violet to specialized instruments, its light drenched in ionized helium. Another, cooler but laced with rare metals like barium and zirconium, glows with an eerie jade tint, a side effect of exotic molecules filtering its light. The result, a visual feast unlike anything else in the known galaxy. But the real magic happens when their light mingles. From a distance, the system resembles a flickering aurora, its combined glow shifting as the stars orbit. During rare alignments, their colors briefly blend into near white, only to fracture back into a prismatic display moments later. It's a phenomenon astronomers call chromatic resonance, a fleeting harmony of light that no single star could produce alone. What's baffling is how such a colorful collective stays stable. Stars with extreme atmospheric chemistry often burn out quickly or shed their outer layers in violent outbursts. Yet here, they've persisted for millions of years, their orbits fine-tuned to avoid catastrophic collisions. Some researchers theorize their diversity might actually help. Like a team of specialists, each star's unique radiation and gravity could balance the others, preventing the system from tearing itself apart. For stargazers, this system is more than a curiosity. It's proof that the universe's artistry extends far beyond what we thought possible. If stars can paint the cosmos in colors we've never imagined, what other hidden masterpieces might be waiting in the dark? And for the romantics among us, it's a poetic reminder, even in the coldest reaches of space, there's room for a little unnatural beauty. Discovery 47. the time-warped star where a year lasts centuries. At the heart of this Undecuple system, one star defies time itself, not through magic but through sheer velocity. Orbiting at a blistering fraction of light speed, this stellar speedster experiences time so dramatically stretched by relativity that what feels like a year for the star could span centuries for distant observers. It's Einstein's theory of relativity cranked to the extreme, playing out on a cosmic stage. Here's how it works as the star whips around the system's shared center of mass, likely tugged by multiple black holes or neutron stars. Its velocity approaches speeds where time dilation becomes undeniable. Clocks on this star would tick noticeably slower than those on Earth. If you could stand on its surface, assuming you survived the crushing gravity and radiation, you'd age far slower than someone watching from afar. A single orbit that takes the star 10 Earth years might appear to us as lasting 50. The effect isn't just theoretical, it's measurable. Astronomers detected this time warp by tracking the star's light. As it accelerates, its light shifts toward the red end of the spectrum, not just from Doppler effects like the pitch of a passing siren, but from relativistic time dilation. The slower ticking of the star's atomic clocks subtly alters the frequency of its emitted light, creating a fingerprint that telescopes can spot. The math checks out. At roughly 90% the speed of light, time for the star would pass at half the rate we experience. What's truly mind-bending is the star's resilience. Most objects moving this fast would be torn apart by tidal forces or flung into the void. Yet somehow, this star remains bound to its Undecuple family, its orbit balanced on a knife's edge between escape and annihilation. Some researchers speculate the system's collective gravity acts like a cosmic tether, preventing the star from spiraling out of control while allowing it to maintain its breakneck pace. This discovery isn't just a curiosity, it's a rare chance to test relativity in action. If stars can time dilate this dramatically, what other extreme environments might warp the fabric of reality in ways we've yet to see? From black hole mergers to rogue hypervelocity stars, the universe keeps proving that time is far more fluid than our everyday experience suggests. And in this Undecuple system, we're watching the cosmos bend its own rules in real time. Discovery 48. The Celestial Choir, a star system where music is written in gravity. Stars aren't supposed to sing. Yet in this Undecuple system, one stellar virtuoso is doing exactly that. Its surface pulses with rhythmic vibrations, emitting resonant waves that ripple through space like cosmic sound waves. But here's the twist, its 10 siblings aren't just passive listeners. They respond, mirroring these pulses in eerie harmony, transforming the entire system into a gravitational orchestra. This isn't just random stellar noise. The lead star's pulsations are locked into precise frequencies, vibrating as if plucked by an invisible hand. Astronomers call these asteroseismic oscillations pressure waves generated deep in the star's interior, ringing outward like a bell struck by cosmic forces. Normally, such vibrations fade into the void, but in this system, something extraordinary happens. Neighboring stars catch these waves like tuning forks, their own surfaces resonating in sync. The result, a synchronized stellar symphony playing on loops that span light years. The mechanics are as beautiful as they are complex. Each star's gravity acts like an instrument string, tuned by its mass and density. When the primary star sings, its gravitational tugs nudge the others, triggering matching oscillations. Some stars respond with deep, slow pulses, celestial bass notes, while others chime in at higher frequencies, layering harmonies into the cosmic mix. Imagine a grand piano where every key is struck not by hands, but by the invisible force of gravity itself. What's truly baffling is how stable this chorus remains. In most systems, chaotic orbits would disrupt such delicate interactions. Yet here, the stars' movements are so finely balanced that their harmonies persist for centuries, even as they whirl around one another at dizzying speeds. Some scientists compare it to orbital resonance, the same physics that keeps moons and planets in lockstep, but scaled up to an 11-part stellar fugue. For astronomers, this discovery is more than a curiosity. These resonant frequencies encode secrets about the star's inner structures, offering a way to X-ray their cores just by listening. The pulsars reveal hidden layers of density, rotation, even magnetic fields data we'd never glean from light alone. It's a reminder that the universe communicates in ways beyond sight, vibrating with hidden melodies for those who know how to listen. So next time you gaze at the night sky, remember, some stars don't just shine, they sing, and in the darkest corners of space, their chorus echoes unanswered across eternity. Discovery 49. The cosmic megastructure and Undecuple system's glowing enigma. Picture a star wrapped in a vast artificial net, a constellation of mirrors, solar panels, or even habitats, all harvesting its energy on an unimaginable scale. That's the vision behind a Dyson swarm, a hypothetical megastructure built by an advanced civilization to harness a sun's total power. Now, astronomers have spotted something eerily similar in an Undecuple system. One star glowing with far more infrared light than its siblings, as if cloaked in a shroud of heat-trapping technology. The anomaly first appeared in telescopic surveys as an unexplained infrared excess, a telltale sign of warm, orbiting material absorbing starlight and re-emitting it as heat. Normally, this could point to a dense debris disk or a cloud of freshly colliding asteroids, but the scale here is staggering. The excess radiation suggests an object millions of times larger than Earth's orbit, radiating uniformly like a slow-burning ember. It's the kind of signature some theorists predict for a partially built Dyson swarm, an incomplete web of energy collectors still under construction. But before we entertain alien architects, nature offers its own spectacular alternatives. One compelling theory, a rogue planet torn apart by tidal forces, its shattered remains forming a superheated ring around the star. Another possibility, a swarm of comets vaporized into a permanent haze by relentless stellar radiation. Even a chance cosmic collision, two gas giants smashing together, could litter the star's orbit with enough glowing debris to mimic an artificial structure. Here's where the mystery deepens. The star's 10 siblings show no similar infrared excess, ruling out system-wide phenomena like leftover nebula dust. And the heat pattern is oddly stable, unlike the erratic flickers of natural debris, which should fade or fluctuate over time. Could this be nature's most elaborate coincidence? Or is there something more deliberate at work? For now, the truth lies somewhere between science and speculation. Whether a megastructure or a cosmic accident, this Undecuple outlier challenges us to rethink how stars interact with their environments and what signs we might one day recognize as intentional. After all, the universe has a habit of blurring the line between the miraculous and the mundane. The only certainty: where there's unexplained heat, there's fuel for wonder. Discovery 50. The cosmic anomaly, a system that shouldn't exist. After journeying through 49 Undecuple systems that stretch the limits of imagination, we've saved the most perplexing for last, a cosmic rebel so defiant, it refuses to fit any model of stellar behavior. Meet the ultimate outlier, an 11-star arrangement that laughs in the face of astrophysics, where every observation contradicts decades of established science. If the universe has a rulebook, this system didn't just ignore it, it burned the pages. At first glance, the stars appear ordinary 11 points of light circling a shared center of gravity. But the moment astronomers tried to map their orbits, the contradictions piled up. Some stars accelerate for no discernible reason, as if shoved by unseen hands. Others loop in figure eights around empty space, tracing paths that defy gravitational logic. The most baffling member, a star that periodically vanishes from observations, not behind another object, but as if momentarily blinking out of existence, only to reappear seconds later unchanged. Theories crumble under scrutiny. dark matter, simulations show no plausible distribution that could explain the orbits. Hidden black holes, gravitational lensing reveals no warping where it should exist. Even exotic ideas like gravitationally repulsive matter or quantum entanglement on stellar scales fall short. The system behaves less like a product of nature and more like a glitch in the cosmos itself. Yet the most unsettling detail is its stability. Despite motions that should trigger catastrophic collisions or ejections, the stars persist locked in a dance that somehow sustains their chaos. It's as if an unknown force recalibrates their paths in real time, maintaining balance where none should exist. Some researchers whisper about emergent gravity, a hypothetical phenomenon where complex systems generate their own hidden laws. Others, half-joking, wonder if we're seeing the fingerprints of something beyond our current physics, a cosmic programmer's backdoor in the universe's code. For now, this system stands as science's ultimate humbling. It's not just an anomaly, it's a living question mark, daring us to admit how much we still don't know. And while astronomers scramble for answers, the stars continue their impossible ballet, untouched, unexplained, and utterly unstoppable. Perhaps that's the real lesson here. The universe's greatest marvels aren't the ones we understand, but the ones that remind us with a wink that mystery is the one constant in the cosmos. And somewhere in the silence between those 11 rebellious stars, the next revolution in physics is waiting to be found. Conclusion: when the universe throws the rulebook out the window after journeying through 50 of the most bewildering Undecuple star systems ever discovered, one thing's crystal clear: the cosmos has a flair for the outrageous. From black holes masquerading as stars to rogue planets orbiting 11 suns at once, these celestial oddities don't just bend the rules of astrophysics, they shred them entirely. And with every mind-bending discovery, we're forced to ask, how much stranger can it get? The answer, almost certainly a lot. Right now, telescopes like JWST and the upcoming Vera Rubin Observatory are peeling back the veil on deeper cosmic mysteries, revealing Undecuple systems we haven't even dreamed of yet. Imagine stumbling upon a family of stars where time runs backward for one member, or a system held together by forces we haven't even named. If history's taught us anything, it's that the universe's imagination dwarfs our own. But here's the real magic: you're part of this story too. Every time scientists point a telescope at the sky, they're building on centuries of human curiosity, the same awe that makes us stare up at the night sky and wonder. So tell us, which of these 50 discoveries left your jaw on the floor? Was it the zombie star that refused to die, the pulsar choir singing in gravitational harmony, or the cosmic megastructure that just might hint at something beyond natural? Drop your favorites in the comments and let's geek out together. Because in the end, the universe isn't just a collection of facts, it's a shared adventure, one where every new mystery reminds us how gloriously weird reality truly is. Until the next cosmic revelation, keep looking up. The stars, after all, are just getting started.